Hey guys, I'm Shane. I was the lead programmer for this group.
Hi, I'm Trush. I was a documenter for this group.
Hello, I am Yao. I was a manager for this group.
In this video, we will be presenting our color animation project.
So essentially what we did was we took an image either from a video or just a regular old image, and we determined what colors compose that image, each individual pixel. So this is our driver class. It's basically what runs everything. All the objects are created here and it just moves the program along. This is the color proportions class. This is the class that determines the color of each pixel and then determines the percentage of the color of the total image. So if it's like 70% black, then it says that it's 70% black. And this is the color line. It basically stacks those proportions on top of each other so that it ends up equaling 100, since you can't have more than 100%. And then we also have a bar graph, which is sort of like the color line, except it's sort of just more spread out and a bit more organized. And the graph interface, this is for the bar graph class and the 3D cluster class, because obviously with any kind of graph you need data, title, some kind of values, and a plot, and obviously axes and labels for them. We also took the initial image that we had and we manipulated it to look a little bit different. Here we basically just flipped the reds and the greens so that if it was initially green it would look red. We also dimmed the brightness quite a bit so that it looks a little bit more black. Probably the coolest class that we have though is the 3D cluster class. We looked at 32 different colors in our image. We didn't look at every single possible RGB value, but essentially what we did was for all 32 colors we created these clusters on this 3D plot, so X, Y, and Z, and we placed them at different points, and depending on how great of a proportion they had, the bigger the cluster would be. So there would be like 32 dots if it was 32%, versus if it was 0.7% there would only be one dot or something like that. So yeah, that's pretty much the whole MATLAB code. So I'll be showing you guys that right now. Alright, so now I'll show you guys the Java class. So this is the main class. It's sort of like the driver script in MATLAB. It's where all the objects that we need are created. It's also where we determine where we want to get our image from. Essentially what we're doing with Java is we are speeding up the process of showing the whole video and the whole color line, because it takes like a long time in MATLAB. So we basically render it in MATLAB and then show the results in Java, which is a lot quicker. So the tabs class, this basically creates the whole GUI that we see in Java that you'll see in a moment. This file picker class, it basically determines what video or image that we want to look at. It actually just runs through the different directories that we have. So we have about 10 images, or 5 images and 5 videos that we want to run through. So this will run through all 10 without any repeats. And this is the color proportions class. It is similar to the MATLAB class, except all it does is it takes the proportions already determined in MATLAB and brings them over to Java through a text file. And we basically did this in order to be able to manipulate an Arduino to be able to point to a certain color with a servo that had the greatest proportion out of the image. So I'll be showing you guys this code in just a moment.
Hi, my name is Trush. I'm the documenter for this group. What I'm doing in this project is making a servo spin, have an RxTX set up so we can run Java code and Arduino code at the same time in Java, demonstrating that the servo moves the way it should. Here's a breadboarding that I did. This is a circuit board, the Arduino circuit board. This is a capacitor. This is the breadboard, and that's a servo. Here's part 1 of the Arduino code. Here's part 2 of the Arduino code, and here's part 3. I'm going to be going over the Arduino code. So the hashtag include servo.h as a library for the servo. Servo is used in codes to make the specific servo do something. Else if statements allow us to make different position changes depending on the expression. Servo.attach9 is a jumper wire attached to this pin on the circuit board. Serial.println, the color is red. It prints the color is red in the serial monitor. Servo.write1 moves the servo 1 degree up. And delay 10,000 basically means 10 seconds later, move on to the next part of the code. Here's RxTX part 1, RxTX code part 2, and RxTX code part 3. RxTX basically allows us to communicate Java and Arduino with each other. If you use our code, you'll know it works if you see this output. The only part of the RxTX code you have to worry about is to make sure that the port name matches up to your OS. And here's a demonstration of me running the Arduino code. The servo will move 162 degrees, and then 10 seconds later it will move back to position 1. Conclusion. We made a servo move at different positions, ran the Arduino code in Java, demonstrated that the Arduino code works. If we had time, we would put an array list that Shane created in Java that outputs the index of the color with the highest color proportions and have it sent to Arduino and the else if statements. After that, we would create a color wheel and have it land on the color with the highest color proportions. Thank you.
One of the things that we also wanted to talk about was the practicality of our work and what it can be used for. One of the ideas that we discussed was the fact that it could be used for security systems where you could determine whether or not a person was allowed to be in a certain place. So for example, if you set up a system where you detect non-color blue, so if anybody's wearing color blue at a specific time and place, the alarm will go off. So in order to indicate that, hey, you're not allowed to be here, and then an alarm will be there and cops will be there.
Alright, so thanks for listening to us ramble, guys. We just want to thank everyone who helped us.
Yeah.
Professor Moyer, Professor Martin, who helped us, who was sort of the inspiration for this project, along with Theodore Gray, who has a very similar project to us in his Disney animated app. So yeah, we just kind of want to thank everyone for listening to us and for helping us out with this project. It probably wouldn't be as good as it is right now in such little time if it wasn't for our two professors and Theodore Gray. So thank you guys.
Thank you.
Thank you.